ancient times, or people use it traditionally from generation to generation, that is called conventional sources of energy. So conventional sources of energy, that is called traditional sources of energy, which people use from ancient time, that is called conventional sources of energy. The best example is fossil fuel. What do you mean by fossil fuel? Dead remnants of plants and animals. Dead remnants, that is called dead bodies of plants and animals, or dead parts. Fossil fuel means dead parts of plants and animals. Dead remnants or dead debris of plants and animals buried under the earth crust for a long period. Millions of years ago, you know that earth was covered with green trees only. Forests are there only. Okay? No civilization took place at that time. So, at that time, because of some natural calamities or earthquake or any other natural calamities, if this forest destroyed and the big tree and plant buried under the earth crust over a long period of time, inside the earth crust different temperature and pressures are there. Because of different temperature and pressure, this debris converts into fossil fuel. Okay? They converts into mineral coal. If the animal body in the ocean or in the terrestrial part, it's in the forest, if animal body is buried under the earth crust over a long period of time, because of heavy temperature and heavy pressure inside the earth crust and inside the ocean, they convert into fuels. They are known as petroleum. So in this way, these type of fuels are called fossil fuel. You know that combustion of fossil fuel produces smoke. Though its calorific value is high, so it produces high amount of energy, but it produces pollution. How to reduce it? So reduce the use of the fossil fuel gradually and use unconventional sources of energy instead of conventional sources of energy. Right? So as for example, you can say that we are dead parts of plants and animals, how it forms. After that, as for example, mineral coal, mineral oil, which is also known as petroleum. Okay, coal and petroleum are the major sources. From this we can produce LPG, liquefied petroleum gas. We can produce CNG, compressed natural gas. These are the produced from this petroleum. This is from the sedimentary rock from which petroleum obtained. You know that you have learned in essence that sedimentary rock is formed inside the ocean. Okay, so if petroleum doesn't come out, then only gas come out, and this gas is known as LPG or CNG. In LPG, mainly butane is present, and in CNG, mainly methane gas is present. And from biogas also you can find out it. Biogas also contains mainly methane. Calorific value of butane is only 50 kilojoule per gram. Per gram 50 kilojoule. Okay, 50,000 joule or 50 kilojoule energy is produced, whereas in methane 55 kilojoule per gram energy is produced. So methane gas with CNG and biogas is better option than that of the LPG. Okay. In your textbook, it is also given one example. In the figure number 14.2, a model demonstrates the process of thermoelectric production. Here the small experiment is given with the help of the pressure cooker. in the pressure cooker, if you heat the pressure cooker, means if you take some amount of water and heat the water in the pressure cooker, then water converts into vapor. Vapor comes out with the pipeline and it falls on it inserts on the fan, small fan made up of a toy. Then the fan can rotate easily. Whatever mechanical energy produced by the fan is connected with dynamo, so dynamo can run, and dynamo converts the mechanical energy into electrical energy, so bulb can glow. So in this way we can find that steam converts into mechanical and then electrical energy. So we can get mechanical energy as well as electrical energy because of this heat energy produced, right? This is the conversion of heat energy. Now, another sources of energy is thermal power plant. Thermal power plant, it's a conventional sources of energy that in Latin language thermo means heat. So heat is produced, and because of the production of heat, mechanical energy and electrical energy is produced. This is the principle or funda of this thermal power plant. So thermal power plant, in this thermal power plant it is said that a power plant in which the heat required to make steam and it drives the dynamo, its mechanical energy is produced. So you can say that production of heat energy, because of the heat energy, mechanical energy is produced. And from mechanical energy we can produce electrical energy. So production of mechanical energy and electrical energy produced in a plant with the help of mineral coal or mineral oil, petroleum or coal are used to produce heat. Okay, this is called the conversion of heat energy. Alternative source of energy, it is called the hydroelectric energy or hydro power plant. Hydro power plant is also called hydroelectric energy. Hydroelectric energy is also known as hydral energy. You have learned the law of conservation of energy. That the energy can neither be created and nor be destroyed, but it can transform from one form to another form. So here it can transform from one form to another form on the dam. Suppose water is there, okay, then it contains potential energy. Potential energy is present in the water. When the dam is open, then water falls down. When water falls down, then potential energy converts into kinetic energy. You know that when this water falls down, that it can run a big dynamo, a huge dynamo when it falls. Okay? So kinetic energy and potential energy together known as mechanical energy. With the help of this mechanical energy, dynamo can run. This is suppose dynamo. When dynamo runs, mechanical energy is produced, then this energy is carried through a wire or a pipeline and then it passes through electrical energy. That means mechanical energy produced and converts into electrical energy. This is the theme of hydro power plant. Okay? The advantage of this hydro power plant is what? It produces electricity by using flowing water, means conversion of mechanical energy. And so what happens when rain is falling? Then we can collect the rainwater into the dam, and so we try to increase the potential energy. You have also learned in ninth standard that to increase the potential energy, you need height. Means dam is prepared at certain height, and so that it increases the potential energy, the level increases. When it falls down from certain height, then it directly converts into kinetic energy, and potential and kinetic together known as mechanical energy. Advantage is what? Advantage of hydroelectric power is what? It is not conventional sources of energy, but it is called unconventional sources of energy. Right? Unconventional sources of energy means it does not produce smoke, it doesn't produce residue. 100% smokeless and residue less energy is there. Moreover, plenty amount of energy is produced, its calorific value is also very high. But the disadvantage is what? To make the big dam on the river, you have to destroy many forests sometimes. You have to clean many surfaces of the earth. Okay, and so biodiversity, it affects the ecosystem, it affects the biodiversity. And that's why the food chain and food web maybe comes in danger. This is the disadvantage of this hydroelectricity. Second thing, hydroelectricity power plant, it can be established and it can be constructed only at certain places. So at that places mechanical energy and electrical energy are produced. Now mechanical energy and electrical energy, whatever produced at that place, if you want it in a city area, then to transfer this electrical energy and mechanical energy is quite costly. And that's why this is also the disadvantage of this hydroelectric power plant. Though at that place we can produce high amount of energy with low cost. Okay, so this is about hydroelectric power plant, advantage of generating hydroelectricity and disadvantage of generating hydroelectricity that I explained you. Now the third one is wind energy or windmill. Wind energy is also unconventional sources of energy, the new source of energy for the human being. It is not used for a long since from the ancient times. You know that to produce wind energy we should plant or establish windmill. And you know windmill, what happened? Yeah. When there is a flow of air, that is called wind. When wind flows or wind blows continuously, at that place this windmill rotate, the blade rotate continuously. If blade rotate, then it produces this wind energy, converts into mechanical energy. And here this pipeline is there. Okay, it converts into pipeline and dynamo is kept here. This dynamo converts the mechanical energy into electrical energy. So in this way we can get mechanical energy and then electrical energy also. So what is the advantage of this windmill? Advantage of this windmill or wind generator is what? It is an unconventional source of energy, smokeless, residue-less, okay? High amount of calorific value is produced, so that high amount of electrical energy is also produced, and it is mostly probably free of cost. Once it is established, after that it is free of cost. So these are the advantages of this windmill or to produce wind energy. What are the limitations of this windmill or what are the limitations of the production of wind energy? First thing is what? Its cost. To establish the big windmill is very, very costly. Second limitation is what? Windmill can be established or placed at the region where there is a high amount of wind continuously blow, and this type of regions are very less on the earth. It can be placed on the mountain or at seashore or a desert area. So to establish on the mountain it is very costly. At seashore the land availability is very less. In the desert area also to establish this is very costly. Transportation of this parts of the windmill from one region to desert area is very costly. Okay. Second thing, whatever electrical energy produced here, transportation of this electrical energy from that place to each place, seashore or mountain or desert area, from that place to transport from that place to inner side of the country, it is very costly, and that's why limited windmills are available in the country. So these are the limitations of wind energy or windmill, of unconventional sources of energy. Right? Here it is given in your textbook that to run this windmill, the speed of the wind should be higher than 15 km per hour, one line distance. To run this big windmill, wind can blow with this speed more than 15 km per hour, then windmill can rotate. Otherwise, it is the dead investment. Right? This is about windmill. Now we are going to learn about the alternative or non-conventional sources of energy, the best sources of